So we're going to have a look at some index laws over the next few lessons, and we're going to spend the first lesson just kind of revising stuff that we've done before. So let's start off with a few questions, right? So what index laws do you actually remember? Here are a few questions for you to do. I want you to pause the video, see what you remember, just have a go at them, why not? And then I'll go through the answers and we'll talk about the laws they represent, okay? That's my puppy saying, pause the video now. Okay, so you have unpaused. Let's see how you do. So x to the power of 5 times by x to the squared, x to the power of 2. Now, when you're multiplying like base numbers together with different powers, you add the two powers together. So you do 5 plus 2. So this would simplify to x to the power of 7. Okay, now we've got x to the power of 5 divided by x to the power of 2. When you're doing divide, it's the opposite of multiply. Instead of adding your powers, you subtract them. Hopefully you remembered that. So it will be x to the power of 5 take away 2, which is 3. That is a 3, honest. Okay, what about this one? X to the power of 5 over x to the power of 2. Well, this still means divide. In a fraction, that line means divide. So you do the same thing as we just did. You subtract the two powers. 5 take away 2 leaves the 3. The pen's being really rubbish today, isn't it? It's not me, honest. What about, say, you've got a power here, x to the power of 5, and that's in a bracket, and the whole thing is squared. Well, let's think about what that means. It means that whatever is in that bracket, in this case x to the power of 5, is times by itself. Well, we know from our index laws, from the first one, that we add the two powers together. Now, a quicker way of doing that is to just multiply these two. You're doing 2 times the 5, means it's x to the power of 10. And what about x to the power of 0? Well, that's 1 straight away. Right, anything to the power of 0, doesn't matter what it is. So a to the power of 0, that's 1. If it's 300 to the power of 0, that is also 1. Anything to the power of 0 is 1. Except for 0 to the power of 0. But don't worry, that's not going to come up in your exam. So here are the rules. We have, if you're multiplying two base numbers together that are the same, and they have to be the same for it to work, you can add together the two powers. If you're dividing, then you subtract the two powers. The first one, take away the second one. Definitely that way round. And this is the same, because this is also divide. So you still subtract your powers when you're doing it with this kind of fraction line. If you're raising something that's to a power, raising it to another power, then you multiply the two powers, and anything to the power of 0 is 1. Okay. Some harder examples then. Right, 5 and the power of 2. Okay, so x to the power of 5 times by x to the power of negative 2. Remember, we add our two powers together, so that's 5 plus negative 2. Well, that's the same as 5 take away 2, isn't it? Which is 3. So this is to the power of 3. So watch out for those negatives. You just treat the numbers in the same way you ordinarily would. All right. Okay, now this is more interesting. Now we've got 3 lots of x to the power of 5 and 4 lots of x squared. What do? Multiply the numbers at the front together. They're ordinary numbers. Ordinary numbers, ordinary maths. All right, so 3 times by 4 is 12. And then the powers, we know what to do with the powers when we're multiplying these together. They're the same base numbers, both x. So we add the two powers together. So it's 12x to the power of 7. Okay? So when you've got numbers like that at the front, just treat them ordinarily, just like you would any other time. Okay, 12x7 divided by 2x to the power of 4. And this might be a little bit easier to visualize if we actually write it out as a fraction, because it's the same maths. Just like here, where we multiplied the two ordinary numbers together, we're going to do ordinary maths with these. Ordinary numbers, ordinary maths. So 12 divided by 2 is 6. And then the x, well, it's 7 and 4, and we're dividing, so we subtract our powers. 7 take away 4 is 3. So just write 6x cubed in this case. Okay, now we know what to do normally with this, don't we? Because we know that we just multiply these two powers together. But to sort of describe this, let's imagine writing it out in full. You wouldn't normally need to write it out in full, but it's a good way of describing what's going on. Okay, so we've got it's to the power of 3, so that means everything in the bracket is times by itself 3 times. Now what that means for our normal numbers, normal maths, 4 times 4 times 4. Well, 4 times 4 times 4 is 64. Nothing to do with Zulane. X squared times by x squared times by x squared. We just use our, our first index law up here. When we're multiplying the same base numbers, we add those powers. So x to the power of 2 plus 2 plus 2, which is 6. Yep. So ordinary numbers, ordinary maths. Those you have to cube in this case, so 4 cubed. But the powers here, we multiply the 2 and the 3 to get 6. Okay. Down here, now we've got 2 different letters, but so we'll treat this in like 3 parts. Firstly, we'll deal with the ordinary numbers. And as we know, ordinary numbers, that's where you're supposed to say ordinary maths. Yeah, okay. We'll try it again next time. Right, 5 times 3 is 15. Now, treat each letter one at a time. Deal with the x's first, then we'll deal with the y's and so on. Now, x squared times by x to the power of 4. Remember, add your powers to get x to the power of 6. And then deal with the y's. Y cubed times y cubed. Well, 3 plus 3 is also 6, okay? And you write each letter out, and it's all just kind of touching together because in maths, touching means times. So this is 15, x to the power of 6, y to the power of 6. Okay, what about this one? Now, we've already kind of shown this as a fraction, so we show what we're doing. Ordinary numbers, ordinary maths, right? So 16 divided by 2 is 8. And then we've got x squared divided by x to the power of 4. So that's 2. Take away 4. Now, that doesn't leave 2. You can't just do the big one, take away small one. It's always the first one, take away the second when you're dividing like that. And 2 take away 4 is negative 2. So that's what the power is. Now, we'll learn more about what that means another time, probably next lesson. But for now, we just leave it as a negative 2. That's absolutely fine. And then y to the power of 8 divided by y cubed. So that's 8. Take away the 3. Leaves 5. So 8, x to the power of 2, y to the power of 5. Right, it is your turn to go off. Now, you should have at the start of this lesson or before, you should have registered for Dr. Frost. So I want you now to go off to Dr. Frost, off you fly, and go and do this task here, which is the basic index laws. It'll be in your homework. So there may be 2 tasks today, but that's the one I want you to do first, the basic index laws, okay? If there's another one, leave it for another day. There might not be, I don't know. So pause the video now, and off you go to do that, whilst my puppy tries to eat the back doormat. Okay. Okay, we've unpaused. You've done that task and you've come back. So let's have a look at these then. Here's some more questions for you to do then, just a little bit more practice. I want you to have a go at these. Don't spend, a huge amount of time on these, certainly no more than 10 minutes, and then sort of see where you've got to, okay? So pause the video again, do the questions, and then unpause when you're done or when the time's run out. Yes, Murphy, that's what I thought too. Okay, so you've done the questions or the time's run out. Let's give you the answers. Now, first things first, let's have a look at this. This x on here is really x to the power of 1. So when we're multiplying, we're going to add all of these together. 10 plus 1 is 11, plus the 4 makes 15. You can't just ignore that power. Now this one, we've got the times and then a divide, and you should really probably, because it's times and divide, that's in the same level of bib maths. So brackets, indices, division and multiplication, it's on the same level, so we do these at the same time, then addition, subtraction. So if that's all on the same level, we start at the left, move to the right. So do x to the power of 4 times by x to the power of 11 first, where you add the powers to get x to the power of 15. Then we can do the divide. So this is x to the power of 3, so subtract the 3, and you get x to the power of 12. Next one, right, and we've got a top of a fraction in the bottom. The good idea here is to do the top of the fraction first and the bottom of the fraction separately, and then, add them together. Now, as it happens, there's nothing I can simplify on top here or underneath, But what I'm going to do is do the y. So I can do y to the power of 4. And this y down here is y to the power of 1. Now we're going to subtract that power because we're dividing, because the top is divided by the bottom. So y to the power of 3, 4 take away 1. Now x to the power of 0, of course, doesn't really exist, does it? It's just 1. So that isn't going to affect my sum at all, because 1 times y to the power of 1 is just y1, you know. So there's nothing to subtract here. So x stays to the power of 8. And you could have done that as by doing 8 take away 0, which leaves 8. You know, it all works out. This one, right, remember, multiply your ordinary numbers first. So that's 4 times 3 is 12. And then add your powers. B to the power of 2 plus b to the power of 6 is, or rather times, means you add the powers to get b to the power of 8. Okay, down here, anything I can simplify on top first? Well, yes, there is actually, because I can do the y to the power of 7 divided by y squared over here. Because these are multiplied, I can multiply them in any order, and I'm going to choose to do the y last, so I can do the 7 take away the 2, right? So I'm going to change my fraction, so it's now x cubed times by, let's put the z's in there now, z to the power of 4, but my y's are going to be 7, take away the 2, because we're dividing by that y. So it's y to the power of 5. And the bottom of my fraction, that's x to the power of 1, isn't it? Isn't going to change. So that's going to be, I'm just going to reorder them though, so it's a little bit more obvious. X to the power of 1, then we'll write the y's next. It doesn't matter if you didn't reorder them. I'm just doing it for my sanity. There's a 3 on the end there. Right, so 3 take away 1 is 2, so it's x to the power of 2. And we're going to simplify. I don't need those time signs. I can leave them out. Y to the power of 5, the 3. So 5 take away the 3 leaves 2, so that's y to the power of 2. And then the z will be, what's it, 4 take away the 3, which leaves 1. Now I don't need to write the 1. In fact, it's neater if I don't. Now, you could have written this in any order. You could have also put, if I put or y squared, x squared, z, or z to the power of 1 wouldn't be incorrect, okay? But ideally, we wouldn't write the 1. So it doesn't matter what order they come in as long as the x is squared and the y is squared. Okay, right, 5 times by 6. Remember, ordinary numbers, ordinary maths, so that's 30. H to the power of 5 times h to the power of 6 will be h to the power of 11, because 5 plus 6 is 11. This one then, 4 times 3 is 12. But I cannot put my s and my t together. They are different base numbers, the s and the t. So I should put 12 s cubed t to the power of 4. Yeah. Right, remember, so what are we going to do with here? Now I could write them out all 6 times multiplied by each other, but actually what I need to do is ordinary numbers, ordinary maths. This will be 2 to the power of 6. Now that's 2 times itself each time. So 2, 4, 8, 16, 32, 64 is 2 to the power of 6. And then y, because I told you to, y squared to the power of 6. Remember, multiply these two together. 2 times 6 is 12. 64, y to the power of 12. Now, this one down here, you need to sort out this bracket first. You need to sort of expand it out, you know, square it. So ordinary numbers, ordinary maths. 5 will get squared. 5 times 5 is 25. And then the powers we're going to multiply. So 8, 20, x to the power of 20. Right, we're dividing. So 20 divided by 5. Well, that's going to be tricky, isn't it? So what I'm going to do here is write it out just like a fraction. Okay, now the x's are kind of the easy bit here, because x to the power of 20 divided by x to the power of 8 means I subtract. So the x power is going to be power of 12. 20 take away 8. But these don't neatly divide. But what I can do is divide them both by anything they divide by. So it's just like simplifying a fraction. If I was simplifying 20 over 25, I would divide the top by 5 to get 4, and I'd divide the bottom by 5 to get 5. So I would be left with 4x to the power of 12 over 5, because the 4 and the 5 will not simplify any further. Okay? Right. Well done. Okay, this is the last bit for today. I want you to try and sort of put together all those bits that we've done. Have a go at these 5 questions, and then we'll be done. Okay, so pause the video now. Have a go at them. I really want you just to crack it on. Have a go. Use the laws. The laws are pretty straightforward, but you do need to make sure you're just applying them evenly. Okay, so pause the video. Off you go. We have unpaused. Okay, the answers are, I'm not going to talk about these too much, but minus 5 plus the 7 will be y squared. We're dividing here, so we're going to subtract. So it's going to be h to the power of negative 7, because I've got minus 2, take away 5, it's negative 7. Remember, ordinary numbers, ordinary maths. So the 3 needs to be cubed, which is 27. And then minus 3 times 3 is minus 9, or negative 9. 10 times by 6 is 60. And the r will be 3 plus minus 4, which is r to the power of minus 1. You can't put minus r, it is r to the power of minus 1. Right? Or you could write 60 over r, but we'll come to that next time. Okay, in here I would expand the bracket first. So let's do, or actually simplify the stuff inside the bracket, then square it, then we'll do the divide, okay? So 2 times 3 is 6, m cubed and m to the power of minus 7. We'll add those together to get minus 4. And we're going to square that. And then we're going to divide that by 18m. All right, well, let's square that first bracket. Ordinary numbers, ordinary maths. So 36. Now the power of m will be 2 lots of negative 4, which is negative 8. And then I need to divide that by 18m, which will be 36. Divided by 18 is 2. And then we're going to subtract our powers. Now this is m to the power of 1 really, isn't it? Just m on its own. So minus 8 minus 1 makes minus 9. It's 2m to the power of minus 9. Right, well done. Give your head a slight rest. Or you can go, if you've got some time left over, you could always go back into Dr. Frost and practice those questions again. Or find some more tasks to do. Otherwise, I shall see you next time. Farewell.